Welcome, maths teachers, and all about Desmos. So, computation layer for Desmos activities. Like student will enter the expression to see the graph. I'm gonna focus on this today, and of course, in this video, we'll add multiple components. So basically, we'll add math input and graph, and then we'll set up some codes such that if you enter any expression, you will see the graph. We can use this feature in different questions, like show some points and ask for the graph equation, or ask your students to enter the derivatives or equation of tangent, etc. So let's get started. So of course we discussed we'll focus on different components. Basically we are going to connect graphs and math input. So you can see here there are some points shown on the graph, and you can ask in the input for the expression. For example, x square, you will see the graph. Basically by doing this you are giving opportunity to your students to try, and they can assess themselves actually. So once it's correct, you will see the tick or correct feedback. Another option, for example, you can show some graph in the dotted version, and you can ask your students to match. So for example, it's a trigonometric function, so sin x, and the student will understand, okay, what should I do, add or plus, and or student can actually click on some points on the graph to see some features, and then come up with the idea that what is the principal axis, what is the period, something like that. So for example, 2 plus sine x or 2x. Now he should think about the translation. So 2x minus 90 or 2x plus 90 will definitely work. So we are giving opportunities to students to try and see when they are correct. And we can add some tables and input as well. You can see I have given one graph and asking about equation of tangent. So we can figure out the derivative first, then the gradient, and then the equation. So in the input bar, when student is trying to enter the equation, it will show actually the equation of tangent. For example, we got the gradient is -1. So y equals to -1 times x minus 1 minus 4. See, at that point a student can see the tangent. So of course you can see this also, but let's get started with graph and math input first. Be careful, you need to copy or note down some codes, so maybe you can have something to note down. So first of all, let's add a graph, and let's add one math input. Labeling is important now because we are going to give some codes in the computation layer. So for example, it's on page 7, so I'm giving input 7. Click on graph, edit it as you like. For example, let's try some quadratic function, x plus 3 times x minus 2. And we will show this graph as a dotted version, okay, or some points, and then we can ask students to match the quadratic with this graph. To do that, what we need actually, we need to define another function in the graph like fx. So if you enter add slider, then it won't be connected. So without that, so just keep add slider ready. Now if you don't do any coding, you will not get anything from input box. It means we need to apply some connection between the graph and the input 7. So we'll go to the computation layer, and we'll use this command function. So function was f, and function is always connected with simple function, which is Desmos standard definitions. So simple function, the location is input 7, dot latex. Always go with latex. I will try again. Function f, simple function, input 7. It's important, the location is important. Dot latex. So because it is twice, so we will delete one. And to see, there is no warning sign. So function was defined in graph and connected to the input. You can see now only one code, that's it. Look, as soon as you type x plus 2, x minus 2, and you will see the graph. You can see x square minus x minus 3. It's not happening. Okay, maybe student will try to change some values and then come up with the accurate answer like this, x square plus x minus 6. So we are giving opportunity to student to see his or her work. So let's try one more. So graph, math input, only one code we are going to use, just one code. So we can write in the title like enter the equation to match with the graph. So student is going to enter the equation in the math input and we'll see the graph. So go edit the graph. Let's try trigonometric this time, sine 3x or 2x, whatever you feel. So let's take sine x, and you can add or subtract some number, for example sine x minus 1. Now to connect with the math input, we'll define another function, for example fx, but you need to remove the slider. So you should see this add slider option, okay, as a warning. So we don't need to define anything in there, but we'll label the input. So input 8, go to computation layer and define it. So function f and simple function as we discussed before, input 8 dot latex. Latex, simple function and function, they always go together. So let's see the preview. Only one code, okay, see, just type sine x, you see the graph, sine x minus 1, it's matching, perfect. So that's how actually, so we can engage our students to try and to come up with their own idea what to do with the graph, what to do with the equations. So you see again, function f and simple function with latex. What we can do now, let's add more components in that. For example, we can add a table, and what I'm going to try here, I'm gonna create a question of equation of tangent. So in the table, I'm gonna ask my students, okay, enter the function which you see in the graph and then find its derivative, so dy over dx, and then we'll give them point where we are looking for the tangent. So let's say gradient at pi over 2 or 90, whatever you want. So pi over 2 and 1, we will check this point what it should be, because it should be on the line. So in the table we can provide some information, and the blank parts it means student is going to enter. We can drag the input part up so that student will try the equation first and then copy in the table. So sine x minus 1, that was correct. So that will be copied from math input to the table. We can do directly from table also, yeah, that's possible, but I'm not focusing on that today. I'm focusing on math input and this. So let's see, sine x minus 1, the derivative is cos x, and then we can find out the gradient. This is nothing to do with coding, it's very simple, but to deal with the coding we will add one more input where I'm gonna ask equation of tangent. So we can add one more input, yeah, one more math input. Yes, it will be below the table, just scroll down. Yes, so try to label it again. Maybe it was, I think, 8, input 8, so we can give it A or something. But before, let's edit the graph. Let's change the equation. Sine 2x minus 1. Okay, that's fine. And then think about a point where you would like to have the tangent. So for that, I'm gonna define gx equals to sine 2x minus 1, and I'll take pi over 2 as my point, x value, and then g of pi over 2, so that we can see this. I think it should be in minus 1. Yeah, you can see on the label to see the coordinates. Now again, we are going to define two functions. One is fx, one is hx. So I'm just clicking on the slider to see the color. So I can change the color and then delete the slider. Delete the slider so that it will remain as the warning here, so that we can connect it with the input 8a, the second input. Yeah, so input 8a or b, whatever, it's up to you. So I have two inputs now, 8 and 8a. So both we are going to connect with the computation layer of graph. So function, it was h this time, simple function, input 8a dot latex. I believe after doing these 3-4 examples, you can definitely apply this. Let's see the preview. And yeah, we can check different things, or we can edit the things here. For example, the point, what was the gradient point. Now to know that, we can check what was that point. I think it was pi over 2 and minus 1. Yes, yeah. So we should have this point in the table. So I'm gonna edit it. So pi over 2 and minus 1. Let's see the preview. So in the first input, student is going to enter the graph to match with this. So it's maybe sine 2x or x. I think it was 2x minus 1. Perfect. So it's matching. So student will copy in the table now sine 2x minus 1. And now let's figure out the derivative. So sine derivative cosine of 2x times 2, just because of the coefficient. And now gradient, because we just have x, so we will substitute pi over 2. So cosine twice of pi over 2 is cosine pi, means 180 degrees, and cosine 180 is minus 1. So minus 1 times 2, it should be minus 2. So it's up to the students what he's going to enter here. Like I didn't enter anything, I just entered the values of x, and automatically it was calculated minus 2. So the equation of tangent should be y equals to mx plus c format. So I'm going to use the same one. So y equals to minus 2 times x minus pi over 2 minus 1, because of the y component also. So yes, so student can see it's a tangent line, and everything is there, like two inputs. So we can have different things in one slide. So it's up to you how you want to try these things. So graph, input, table, everything. So I believe you got the code now. The code is very simple in the computation layer of graph, which was only function, simple function. Just try. Thank you.